The morning of June 28, 1942, seemed to be just another routine patrol mission over the French coastline for Pilot Officer Burling Smith of 131 Squadron. He lifted his Spitfire, Mark VB, serial number AB910, from the grass airstrip at RAF Perp in Cornwall, joining 11 other fighters for a sweep across the Channel. The Rolls-Royce Merlin engine produced its familiar deep roar as the formation ascended through scattered clouds to 8,000 feet. Intelligence briefs had suggested minimal Luftwaffe activity that morning, leading the pilots to anticipate a standard sortie, maybe a minor engagement with a lone reconnaissance plane. No one could have predicted that within 90 minutes, one of Britain's most prized fighters would be in enemy hands, almost completely undamaged. Smith's predicament began over Cherbourg. A single cannon round from a Focke-Wulf 190, which had appeared suddenly out of the sun, tore through his engine cowling. The Merlin sputtered, threw black smoke, and then seized entirely. In the stark silence that follows engine failure at altitude, Smith had only seconds to make a choice. Gliding back across 60 miles of open sea was impossible. The French coast lay below, dotted with Wehrmacht positions, but a flat pasture near the village of Cretville presented his only viable option. He deployed the landing gear, kept the nose high as his airspeed dropped off, and executed a perfect forced landing. The wheels met the grass, and the aircraft rolled for perhaps 200 yards before coming to a stop. Smith quickly scrambled out, intending to set the aircraft ablaze before German soldiers could arrive. He grabbed for the flare pistol loaded with incendiary rounds, the standard procedure for downed airmen. However, a Wehrmacht squad emerged from the tree line almost instantly, their rifles aimed at him. Behind him sat the Spitfire, its propeller blades slightly bent from the landing, but otherwise perfectly intact. Within an hour, Luftwaffe intelligence officers from Jagdquart II's headquarters were on the scene. They circled the aircraft slowly, almost reverently. The entire airframe was pristine, save for the single cannon hole in the cowling and the minor propeller damage. The landing gear was solid, and the wings showed no signs of wrinkling or buckling. Even the radio equipment was still secure in its mounting. One officer traced his hand along the leading edge of the elliptical wing, feeling the smooth flush riveting that German engineers had yet to successfully replicate in mass production. Another peered inside the cockpit, observing the gun sight, throttle quadrant, and trim wheels, all exactly as British pilots used them. While they had captured Spitfires before, burned out hulks, shattered fuselages, and wreckage that offered little more than twisted metal, this machine was different. It could fly again with just an engine swap and some minor patch welding. The intelligence potential was immense. By nightfall, a low loader truck arrived carrying a Luftwaffe technical recovery crew. They drained the last of the fuel, unhooked the control cables, and carefully winched the Spitfire onto the trailer. The convoy then rumbled east toward Germany under the cover of darkness, avoiding Allied reconnaissance aircraft that might try to destroy the prize. Smith, meanwhile, was beginning his transport to a prisoner-of-war camp, completely unaware that his forced landing had just given the Luftwaffe its most complete look ever at the fighter that had defeated them so decisively during the Battle of Britain. The Germans had long respected the Spitfire's reputation. Their pilots returning from combat over southern England described its incredible turning circle and ferocious rate of climb. Messerschmitt test reports even conceded the aircraft's superiority in certain flight envelopes. But respect built on pilot anecdotes and second-hand intel was vastly different from having the actual aircraft in a hangar available for limitless inspection and flight testing. As AB-910 made its way into Germany in early July 1942, the Luftwaffe High Command ordered Rechlin, the service's main test facility, to prioritize this evaluation above almost all other active projects. They needed precise, measurable data: climb performance, turning radius, stall behavior, maximum speed at different altitudes, and roll rate. Most importantly, they demanded comparison flights against their own frontline fighters to learn exactly where the Spitfire excelled and where German aircraft could potentially exploit any weaknesses. The captured fighter arrived at Rechlin's facilities near Moritz Lake on July 4, 1942. Technicians immediately moved it into a secure hangar, posting armed guards at every door. Even Luftwaffe personnel lacking top-secret clearance were denied access.
The test pilot chosen to evaluate this British prize was already known as one of Germany's most analytical aviators, a man who flew with an engineer's precision rather than a warrior's aggression. His first report would either validate the Luftwaffe's assumptions about the Spitfire or completely destroy them. Hauptmann Hofpingel walked around the Spitfire 3 times before he even touched it. He had flown Bf-109s in combat over France and Britain, amassing 26 confirmed kills before his own forced landing in England led to an 8-month stay in a POW camp. A prisoner exchange in early 1942 returned him to Germany, and the Luftwaffe promptly assigned him to Rechlin's test center. His combination of combat experience and technical insight made him the perfect choice to assess captured Allied planes. Yet as he stood in that hangar on July 5th, examining AB-910 under the bright electric lights, Pingel began to doubt everything German intelligence had claimed about the Spitfire's construction. The first major shock was its weight, or lack thereof. Luftwaffe intelligence estimated a fully loaded Spitfire Mark V weighed around 3,200 kilograms. Pingel's team, after installing a replacement Merlin 45 engine salvaged from another crashed Spitfire, placed AB-910 on calibrated scales. The actual reading, with full fuel and ammunition, was 2,911 kilograms, nearly 300 kilograms lighter than German projections. Pingel instantly did the mental math. That weight reduction directly translated to better climb performance, a tighter sustained turn rate, and superior acceleration, all areas where, according to pilot reports, the Bf-109F already struggled against the Spitfire. If the British fighter was truly this much lighter, the performance gaps were even wider than they had feared. He then moved to the wings. The elliptical planform had long fascinated German engineers. They considered it aerodynamically perfect, but prohibitively expensive to manufacture. Messerschmitt had opted for a simpler, straight tapered wing for the 109, precisely because complex curves required excessive tooling and highly skilled labor. And yet here was a mass-produced British fighter, with wings that appeared sculpted rather than manufactured. Pingel ran his fingers along the underside, feeling the almost imperceptible bumps of the flush rivets. The entire lower wing surface was smoother than anything German factories were producing. He knew from his aerodynamic training that skin smoothness had a direct impact on drag, particularly at high speeds. Every single rivet head that protruded into the airflow cost a few kilometers per hour of top speed. The British had somehow solved a manufacturing challenge that German production engineers had deemed impossible to scale.
The cockpit provided another jarring revelation. Pingel climbed in, settled into the seat, and studied the instrument panel. The layout was logical. The throttle rested naturally under his left hand. The trim wheels were easy to reach, and the gun sight was at a perfect eye level. But it was the visibility that truly stunned him. The bubble canopy offered an almost completely unobstructed view in every direction, except for the area directly behind him. He had flown the Bf-109F extensively, and its canopy felt claustrophobic in comparison, with thick frames blocking sight lines and a head armor plate obstructing the rear view. In aerial combat, seeing the enemy first was often more critical than having a slightly faster plane or heavier guns. If British pilots had this kind of panoramic view during dogfights, while Luftwaffe pilots were peering through narrow glazing, that advantage alone could explain why Spitfires so often seemed to appear from nowhere. Oberleutnant Hans-Werner Lürke, another test pilot on the evaluation team, concentrated on the control system. He removed inspection panels to trace the cable runs from the stick and rudder pedals to the control surfaces. German fighters were designed with stiff control harmony, demanding significant muscle to move the heavy stick, especially at high speeds. The British, it turned out, had designed something completely different. The ailerons responded to mere fingertip pressure, even while the aircraft was stationary. Lürke moved the stick through its full range of motion, feeling the light, remarkably light, resistance. He called Pingel over, and both pilots manipulated the controls, sharing concerned looks. If the control forces remained this light in the air, the Spitfire could achieve roll rates that the Bf-109's heavy ailerons could never hope to match. Rolling performance was often the deciding factor in a turning dogfight.
The fighter that could reverse its bank direction fastest controlled the engagement. The engineering team began dismantling panels all over the fuselage, photographing every single structural detail. They found stressed skin construction techniques that were more advanced than German methods. The metal skin itself was carrying the aerodynamic loads, rather than relying on a heavy internal framework. German aircraft, in contrast, still depended on traditional framework construction, covered by fabric or light metal, incurring a substantial weight penalty. Messerschmitt and Focke-Wulf engineers had insisted the British approach was too complex for mass production. But here was the undeniable proof that British factories were manufacturing these sophisticated structures in quantities that outpaced Luftwaffe fighter production. Pingel wrote his preliminary ground inspection report that evening. Its conclusions were stark. Every pre-war assumption about the Spitfire's construction was wrong. The aircraft was lighter, more aerodynamically clean, better designed for pilot efficiency, and more intelligently engineered than any intelligence estimate had suggested. And they hadn't even flown it yet. The upcoming flight tests would either calm German fears or confirm that the Luftwaffe was facing an opponent even more formidable than the one that had defeated them in the Battle of Britain. The security protocols established for AB-910's flight testing were even stricter than those for Germany's own experimental aircraft. Reichsmarschall Göring personally decreed that no mention of the captured Spitfire could appear in any written correspondence outside the absolute highest command channels. Rechlin's commander set up a perimeter around the test hangar, with Gestapo officers checking the credentials of anyone who came within 200 meters. The Luftwaffe was terrified that Allied intelligence would learn of the intact capture and order a specific bombing raid to destroy this single aircraft. One well-placed Wellington or Mosquito finding Rechlin on a clear night could wipe out months of potential research. Getting the Spitfire flight ready was a meticulous 3-week process. The replacement Merlin engine, salvaged from a crashed Mark V in a French field, had to be completely inspected and bench-tested before installation. German technicians had almost no experience with Rolls-Royce engines, and the Merlin's advanced 2-stage supercharger system was substantially different from the simpler units on Daimler-Benz power plants. Every component had to be verified. The coolant was a glycol mixture slightly different from German specifications, and the ignition timing had to be set perfectly according to separately captured British technical manuals. Even the de Havilland constant-speed propeller posed a challenge, as it operated on hydraulic principles that German engineers found needlessly complex compared to their own electric propeller controls. Painting the aircraft led to a heated debate among intelligence officers. Some wanted to keep its RAF camouflage for potential deception operations, such as flying it low over occupied territories to confuse Allied pilots, or even attempting an infiltration mission. Others demanded full Luftwaffe markings to prevent friendly fire incidents during testing. The compromise was an operational one that satisfied no one. They painted large black and white Balkan crosses on the fuselage and wings, but kept most of the original RAF camouflage. Bright yellow identification panels, the Luftwaffe standard marking for aircraft on the Eastern Front, were added to the nose and rear fuselage. Even though the Spitfire would never see Russia, ground crews also painted White 14 on its sides, designating it as part of the Rechlin test inventory. The resulting hybrid appearance was bizarre, a visual representation of the aircraft's confused identity, British engineering wearing German insignia. Fuel created another unexpected problem. The Merlin engine was built to run on 100-octane aviation gasoline, a fuel grade Britain imported in massive quantities from American refineries. Germany's synthetic fuel crans, hampered by limited crude oil and Allied bombing, struggled to consistently produce even 87-octane fuel. The Luftwaffe's best aviation fuel, designated C3, was rated at 96 octane. Close, but not what the Spitfire required. Engineers determined that using C3 fuel would decrease engine performance by about 3 to 4%, mainly affecting maximum boost pressure at altitude. This meant that all the test results would actually understate the Spitfire's real capabilities. When Pingle learned this, he demanded the discrepancy be highlighted in all reports. If the Spitfire proved superior even while running on substandard fuel, the findings would be that much more alarming. Selecting the test pilot roster was done carefully. Pingle would handle the initial flight tests, but Rechlin's commander wanted multiple pilots to fly the plane and provide independent feedback. They selected 3 more aviators. Lurka, who had studied the control systems on the ground; Hauptmann Emil Quad, a former instructor with over 3,000 flight hours, who could assess its handling qualities objectively; and Lieutenant Franz Stigler, a combat veteran from Jagdgeschwaden 27 who had battled Spitfires over Malta and could compare the real thing to his combat memories. Each pilot pored over AB 910's technical manual, a captured RAF document that German translators had worked through page by page, converting every imperial measurement to metric and every British technical term into its German equivalent.
The weather in late July turned against them, as heavy clouds and rain kept the Spitfire grounded for 6 straight days. Pingle used the time to conduct ground runs, pushing the throttle to various power settings while mechanics watched engine temperatures and pressures. The Merlin's unique sound, higher pitched than the Daimler-Benz engines he knew so well, echoed across Rechlin's airfield. Other test pilots paused their work to listen. It was the same sound that had struck fear into German bomber crews over Britain 2 years prior. The acoustic signature of a Spitfire diving to attack. Hearing it now, coming from a captured British engine adorned with Luftwaffe crosses, created a surreal feeling. One mechanic later noted in his diary that the engine's sound made him deeply uneasy, as if they had caged something that did not want to be captured. On July 29, 1942, the weather finally broke. The morning mist burned off by 9 a.m., leaving behind calm air and perfect visibility. Pingle finished his pre-flight inspection, climbed into the cockpit, and strapped in. The ground crew pulled the chocks. This was to be a cautious first flight. Takeoff, climb to 3,000 meters, basic handling checks, and land. There would be no aerobatics, no high-speed passes, and nothing to stress an airframe that had already survived one forced landing. The intelligence from a single successful flight was valuable enough to justify the conservative plan. They could push the performance envelope later, once they confirmed the aircraft was fundamentally airworthy under German operation. Pingle advanced the throttle smoothly, feeling the Merlin's power surge through the airframe. The Spitfire accelerated more quickly than he anticipated, noticeably faster than the Bf-109F he had flown just yesterday for comparison. The tail came up at 60 kilometers an hour, and suddenly he had a clear view straight down the grass runway instead of having to peer around the nose. At 140 kilometers an hour, the fighter simply floated into the air, requiring no conscious back pressure on the stick. He had expected to have to haul back and force it off the ground, as German fighters required, but the Spitfire seemed to decide for itself when it was ready to fly. The sensation was both unsettling and exhilarating. As he climbed through 1,000 meters, Pingle began to gently test the controls. He had memorized the captured pilot's notes and knew the stall speeds and handling parameters, but numbers on a page could not convey an aircraft's actual feel. He initiated a shallow bank to the left. The ailerons responded with shocking immediacy. The slightest stick movement produced a crisp roll. He reversed the bank to the right and got the same response, light, precise, with no lag between his input and the aircraft's reaction. The Bf-109F demanded firm, deliberate muscle to achieve similar roll rates, especially above 300 kilometers an hour, where aerodynamic forces made the controls incredibly stiff. This British fighter, by contrast, rolled as if it were reading his mind. At 2,000 meters, he attempted his first real turn. He started with a gentle 30-degree bank, holding altitude with a bit of back pressure. The Spitfire carved through the air without any buffeting or tendency to drop a wing. He tightened the bank to 45 degrees, still smooth. Then he pulled into a 60-degree bank, pulling harder on the stick and feeling the G-forces push him into his seat. The turn radius dramatically shrunk, yet the aircraft remained perfectly stable. The buffeting that usually warned of an impending stall never came. He checked his airspeed, 210 kilometers an hour, and it was still flying comfortably in this steep turn. A German fighter would be shaking violently at this angle and speed, demanding constant rudder corrections to prevent a snap roll. Something else grabbed his attention during these turns. The elevator response felt perfectly matched to the ailerons. Neither control was heavier than the other. They worked together in natural harmony. German aircraft typically had mismatched control forces, creating a slight imbalance that pilots had to learn to compensate for. The Spitfire's designers had achieved genuine harmony across all three axes. Rolling, pitching, and yawing forces were all proportionally balanced. The psychological effect was profound. Pingle realized he wasn't fighting the aircraft or managing its flaws. He was simply thinking of a maneuver, and the Spitfire was executing it. This must be what the RAF meant by the Spitfire's forgiving and intuitive handling. He climbed to 3,000 meters and tried some vertical maneuvers, including a half-loop, pulling up and over the top, rolling inverted for a moment. Just as the technical manual warned, the Merlin's negative G carburetor cut out briefly at the apex of the loop, causing a momentary cough before positive G restored fuel flow. German fighters used fuel injection systems that didn't have this problem, but it seemed like a minor flaw. A pilot could simply roll inverted before pulling, maintaining positive G through the maneuver. The climb rate during the initial pull-up impressed him more than the carburetor's flaw. The Spitfire shot upward, converting speed to altitude with incredible efficiency. The throttle response also warranted special note. Pingle had flown dozens of fighter types, and most had a noticeable lag between throttle movement and engine response. But the Merlin reacted instantly. Push the throttle, and power was immediate. Pull it back, and the power dropped just as fast. This was a massive advantage in combat, where pilots constantly adjust their power state to manage their energy. A sluggish throttle forced a pilot to anticipate his power needs seconds in advance. The Spitfire let its pilot react in real time. Combined with the light controls and tight turn, a Spitfire pilot could transition between climbing, diving, and turning with minimal delay. The aircraft simply did what its pilot asked when he asked it. Pingle then deliberately pulled the nose up to bleed off speed and test the stall characteristics. The airspeed indicator unwound, 160, 140, 120 kilometers an hour. The airframe began to buffet gently, providing plenty of warning. At 110 kilometers an hour, the nose finally dropped, but the stall was gentle and predictable. A simple push forward on the stick, an application of power, and the Spitfire recovered instantly, without any drama. No wing drop, no incipient spin. German training aircraft often had vicious stall behaviors to teach pilots respect for the flight envelope's edge. The Spitfire's docile stall meant its pilots could fly right up to that edge without fearing a sudden loss of control. After 40 minutes, the planned duration of the first sortie, Pingle headed back to Rechlin. The approach speed felt slow, under 150 kilometers an hour, giving him ample time to line up with the grass runway. The view over the nose, even in a tail dragger, remained excellent. The touchdown was smooth, with the aircraft settling onto the grass without bouncing. He rolled to a stop and cut the engine. As ground crews ran toward him, Pingle sat quietly in the cockpit for a moment, processing the experience. He then climbed out and walked straight to the operations office. His preliminary flight report took 3 hours to write, and ended with a sentence that would send shockwaves through the Luftwaffe High Command. This aircraft is superior to the Bf-109F in every combat-relevant parameter except
maximum speed above 6,000 meters.
The comparative trials kicked off on August 3, 1942, with Rechlin's top combat pilots taking turns flying both the captured Spitfire and the Luftwaffe's frontline fighters. The methodology was scientific and strict. Timed climbs to specific altitudes, measured turning circles, acceleration runs, and mock dogfights recorded by gun cameras. Every test was repeated multiple times to ensure consistent, reliable data. The Luftwaffe needed quantifiable proof, not just subjective pilot opinions, though those opinions would end up being remarkably consistent. The first head-to-head trial put AB 910 against a Bf 109 F4, the Luftwaffe's primary fighter in mid-1942. Pingel flew the Spitfire, while Lurch took the Messerschmitt. They took off together and climbed to 5,000 meters. The test protocol mandated a neutral start, with both fighters flying parallel before starting a turning fight. On signal, both pilots broke hard toward one another. Within just 2 complete turns, Pingel had the Spitfire locked onto Lurch's tail. The gun camera film showed the Bf 109 desperately trying to outturn the British fighter, but the geometry was hopeless. The Spitfire's tighter turning radius meant every 360-degree rotation brought it slightly closer to a firing solution. After 6 turns, Lurch's only escape was to dive away at full power, using the Bf 109's superior dive acceleration to break contact. They ran the test 5 more times. The only variable was how long the Bf 109 survived before the Spitfire achieved a theoretical kill. In a level turning fight, the German fighter was utterly outclassed. The data proved what combat reports had long suggested. A disciplined Spitfire pilot who stayed in the horizontal plane would defeat an equally skilled Bf 109 pilot nearly every time. Lurch's post-flight report was professional but devastating. Against a Spitfire, we must never enter a sustained turn. Our only advantages are initial acceleration in the dive and marginally better high-altitude performance above 7,000 meters. We must fight vertically, never horizontally. The climb rate comparison was just as sobering. Both planes started from the ground and climbed at maximum power to 6,000 meters. The Spitfire made it in 6 minutes and 42 seconds. The Bf 109F took 7 minutes and 18 seconds. That 36-second deficit translated to an 800-meter altitude advantage in combat. If a mixed group of Spitfires and 109s scrambled together, the British fighters would hold a massive positional advantage by the time they met. German pilots had developed tactics to offset this, usually by gaining altitude long before an engagement, but this required knowing where the enemy would be, a rare luxury in fluid air combat. The roll rate tests produced the most alarming data. Engineers used high-speed cameras to measure the exact time it took each plane to complete a 360-degree roll at various speeds. At 400 kilometers per hour, a typical combat speed, the Spitfire completed the roll in 1.8 seconds. The Bf 109 needed 2.4 seconds. That 0.6-second difference might seem trivial, but in a dogfight, it determined who could reverse bank direction fast enough to track a maneuvering target. The Spitfire pilot could roll inverted, pull through, and roll upright again before the 109 pilot had even completed his reversal. This single fact explained why veteran Luftwaffe pilots felt perpetually behind the curve against Spitfires. They were flying a machine that responded fractionally slower to every command. The captured Spitfire was next pitted against the Focke-Wulf FW-190A3, which had only entered service months earlier. German pilots already considered the FW-190 superior to the Bf-109 in roll rate, armament, and high-speed handling. Surely this newer design would match the Spitfire. Stiegler flew the FW-190, while Quad took the Spitfire. The test started identically: neutral start, brake, and turn. The FW-190 performed better than the Messerschmitt at first, its excellent roll rate allowing Stiegler to counter Quad's maneuvers. But after 3 complete turns, the Spitfire was once again in firing position. The British fighter's slightly tighter turning radius eventually neutralized the FW-190's roll advantage. However, The FW-190 proved clearly superior in other areas. Its dive performance was substantially better than both the Spitfire and the Bf-109. In level flight above 5,000 meters, the Focke-Wulf was about 25 kilometers per hour faster. The German fighter also packed a much heavier punch, with 4 20mm cannons and 2 machine guns, compared to the Spitfire's 2 cannons and 4 machine guns. A single firing pass from an FW-190 delivered almost double the projectile weight. This suggested a clear tactical solution. FW-190 pilots must avoid turning fights at all costs. Instead, they should use boom and zoom tactics, using their speed and dive advantage to engage Spitfires on their own terms and break away before the British fighter could draw them into a horizontal fight. The team also tested the Spitfire against the new Bf-109G Gustav, which was just arriving at frontline units. The Gustav had a more powerful engine, and engineers hoped it would close the performance gap. The results were disappointing. The Bf-109G could climb fractionally faster than the Spitfire below 4,000 meters, but the Spitfire regained its advantage at higher altitudes. And in a turn, the Spitfire was still the decisive winner. The Gustav's heavier engine and armament came with a weight penalty that only worsened its already difficult handling. Pingel's assessment was blunt. The 109G is an improvement in armament and climb, but it remains inferior to the Spitfire in the turning combat that dominates engagements below 6,000 meters. The complete test data, along with the damning gun camera footage, landed on desks across the Luftwaffe High Command in late August 1942. Senior officers watched films of the captured Spitfire, now wearing German crosses, systematically outmaneuvering every fighter in their inventory. The implications went far beyond just admitting British engineering was superior. These findings required immediate changes to tactics, training, and operational doctrine for every fighter unit from Norway to North Africa. The Luftwaffe had spent 3 years fighting based on assumptions about the Spitfire that were now proven to be dangerously false. General der Jagdflieger Adolf Galland, who had led fighters in the Battle of Britain and knew the Spitfire's capabilities firsthand, received the full Rechlin report on August 27th. Even he was shocked by the hard data. The turn differential was worse than pilots had estimated, the roll rate advantage was larger, and the climb gap was wider. He immediately called a conference of squadron commanders. The meeting lasted 2 days and resulted in a revised fighter combat manual that was distributed to every Jagdgeschwadron by mid-September. The new doctrine acknowledged harsh truths and mandated specific tactics to counter the Spitfire's advantages. The core rule was simple: never fight the Spitfire on its terms. German pilots were now expressly forbidden from entering sustained turn engagements unless they had overwhelming numbers. The manual stated it plainly: a Spitfire will outturn any Luftwaffe fighter currently in service. Pilots who attempt turning combat will be shot down. Instead, pilots were ordered to ruthlessly exploit their own aircraft's specific strengths. The Bf-109 was to use its high-altitude performance and dive speed, attacking from above in a single pass before diving away.
The FW-190 was to rely on the same high-speed boom and zoom tactics, never slowing down enough to let the Spitfire dictate the fight. Training syllabi at Luftwaffe flight schools were changed. New pilots had always learned basic dogfighting, but the post-Rechlin curriculum completely de-emphasized turning combat against Spitfires. Instructors now drilled students relentlessly on vertical fighting, gain altitude, dive on the target, fire, extend away, climb, and repeat. This style suited German fighters, but it demanded immense discipline. Inexperienced pilots had a fatal instinct to turn and follow a damaged enemy, a move that was often deadly if that enemy was a Spitfire. The Rechlin data also shifted aircraft development priorities. Focke-Wulf and Messerschmitt engineers were now told to prioritize high-speed performance and climb rate, even at the expense of turning ability. The logic was pragmatic. They would never outturn a Spitfire with small improvements, so it was a waste of resources to even try. It was better to enhance the areas where German aircraft already had an edge, widening those performance gaps to give pilots clearer tactical options.
This philosophy directly influenced later designs, like the Bf-109K and the TA-152, both of which were optimized for high-altitude interception, not low-level dogfighting. Intelligence gathering also received a new sense of urgency. If this Mark VB-5 was so superior, what were the newer models capable of? The Rechlin report specifically warned that the captured plane was likely not the peak of the Spitfire's evolution. British engineers were certainly developing more powerful engines, like the rumored Griffin, which could render all current German fighters obsolete. Luftwaffe intelligence was ordered to prioritize any information on Spitfire development. The tactical shift wasn't purely defensive. The tests had confirmed the Merlin engine's one key weakness, the negative G carburetor cutout. A Spitfire pilot pushing the stick forward into a dive would experience a momentary engine cough. Luftwaffe pilots were trained to exploit this. If a Spitfire was chasing a German fighter, the German pilot could push his stick forward aggressively. The pursuing RAF pilot would instinctively follow, causing his own engine to sputter for a fraction of a second, just long enough for the German pilot to extend his range or reverse the engagement. Formation tactics also evolved. The old tight formations were suicidal against Spitfires. The new doctrine mandated loose, flexible formations with wide spacing, allowing each pilot the freedom to maneuver. The classic four-aircraft schwarm was kept, but with increased vertical separation, so the top pair could dive on any Spitfires that engaged the lower pair in a turning fight. Over Western Europe, Luftwaffe fighters increasingly shifted to a purely defensive role, intercepting bombers rather than seeking out fights with the dominant Spitfire squadrons. The psychological impact was immense. Within months, German pilots began to view encounters with Spitfires as dangerous obstacles to be avoided, not opportunities for victory. AB-910's career in German service continued through the winter of 1942, shifting from pure testing to specialized training and deception. The Luftwaffe realized a flyable Spitfire was a strategic asset. It became a tool for pilot familiarization. Combat pilots who would face Spitfires were rotated through Rechlin to fly it. This demystified the aircraft, proving that while exceptional, it was not supernatural and had flaws. The Luftwaffe also used AB-910 for practice interceptions, training their pilots to recognize and counter Spitfire tactics by practicing offensive maneuvers against a real Spitfire. Intelligence even proposed using AB-910 for infiltration missions over Britain, but the plan was shelved as being too risky. The plane would almost certainly be identified as hostile and shot down, destroying an irreplaceable asset. The Spitfire also served less glamorous roles, like testing captured British equipment. A British gyroscopic gun sight was tested in AB-910 and found to be superior, leading to accelerated German development of their own gyro sights. By early 1943, AB-910 had logged about 80 flight hours in German hands and was showing signs of wear. The patched-together engine was burning oil, and the landing gear was becoming unreliable. Rechlin's commander had to decide whether to ground the priceless asset or risk its destruction. Allied bombings made the decision for him. On the night of April 17, 1943, an RAF raid on Berlin saw several damaged bombers jettison their loads randomly on their way home. One stick of bombs fell on Rechlin's airfield. A single 500-pound bomb punched through the roof of AB-910's secure hangar and detonated 15 meters away. The blast wave crumpled the Spitfire's fuselage, tore off a wing, and riddled the engine with shrapnel. AB-910 would never fly again. Technicians salvaged every usable part. The engine went to Daimler-Benz for analysis. The controls were preserved for study, and the airframe was used for stress analysis. Even in death, the captured Spitfire continued to serve German intelligence. The test reports, gun camera footage, and engineering data from AB-910 remained in active use for the rest of the war, shaping every subsequent German fighter design and tactical revision. The legacy of AB-910's capture rippled through German aviation long after its wreckage was cleared. The hard data forced the Luftwaffe to acknowledge that British engineering had outpaced them in critical areas. This directly influenced the Me-262 jet fighter. The Rechlin data proved it was futile to try and outturn a Spitfire, so the Me-262 was designed to use raw speed to make turning irrelevant. Similarly, the Focke-Wulf Ta-152 was designed as a specialized high-altitude interceptor, focusing only on the single-flight regime where German fighters had a measurable advantage. The tactical doctrine of boom and zoom became standard, as pilots were trained to avoid the horizontal turning fights the Spitfire excelled at. The intelligence value also extended to subsystems like the IFF and radio, which helped German signals intelligence track RAF formations. The capture also served as a cautionary tale, prompting Germany to enact stricter protocols for destroying their own downed aircraft to prevent a similar intelligence windfall for the Allies. Pilot Officer Burling Smith, the man who had landed the plane, spent the rest of the war as a POW, never knowing his aircraft had become Germany's most studied British fighter. After the war, Allied intelligence teams sweeping Germany recovered the complete Rechlin test reports. Ironically, British and American engineers were deeply impressed by the meticulous, systematic methodology the Germans had used to test the Spitfire. And those German techniques went on to influence Allied post-war aviation testing standards. AB-910's capture, the result of a single unlucky cannon shell, demonstrated that one intact piece of enemy technology, methodically evaluated, could provide intelligence that would shape an entire Air Force's doctrine and development for years.